Now that we have the good understanding of volumes, now let's create our very first simulation. We're going to create the smoke simulation, and we are going to create the smoke simulation inside of DOPS, inside of the dynamic operators. So DOPS is the dynamic context that we haven't talked about yet. So let's dive inside the DOP and let's create our very first simulation. First, let's create a geometry node. I'm going to create a SOP container because inside of the DOPNet, if I create a DOP network, here as you can see we have the DOPNet and I'm inside. That is our dynamic context. And in here we need the source for emitting our smoke simulation. So that is why we are going to create our source inside of SOPs. And for sourcing, I'm going to just create a simple box. Let me view this. So this box will act as an emitter, our smoke emission source. So let's bring up the parameter of the box and I'm going to increase its size. So let's continue increasing its size to some value. Let me zoom out and let's also increase the size in this axis as well. And now that is a polygonal piece of geometry, and because we are going to create a smoke simulation, we need to convert this into volume. Let's create a VDB from polygons node and let me connect this. And right now it's creating the surface VDB because the smoke simulation is a fog type volume. So which means we need to convert this into fog VDB. So let me undo this and enable the fog VDB. Okay, so we have the volume, and now let's bring this volume inside of DOPS for simulation. So the way that we can do that, here as you can see, we inside into the DOPNet, we have some of these inputs. Either we can connect this or you actually do not need to connect this like so. You can just dive inside, and in here we can import this source, this VDB from polygons, this volume source inside of DOP. So let's see how we can do that. So let's dive inside of the DOPNet and to create the dynamic simulation. So all of these simulations have a certain type of structure. So let's see how we can create this. First, we need to create a smoke object. So let's create a smoke. If you type smoke, and here as you can see, we have all of these nodes. First, we have the smoke object and the smoke solver. And down here, we have another smoke object and smoke solver. And here as you can see, it says sparse. So we have two types of solver inside of Dynamics to creating the smoke simulation. We have this smoke object and smoke solver. These are non-sparse solver. And the smoke object and smoke solver with sparse in here, these are the sparse solver, and these are more efficient and faster. So let's use the sparse solvers. First, we need the smoke object. Sorry, I accidentally select the wrong node. Let me remove this and let's type again. Let's add a smoke object sparse. So here we have the smoke object. This smoke object will store all of the attributes, the information and the data that needed to calculate our simulation. That is why we have the object. So any kind of simulation, either you are working with RBD, if I type RBD, and here as you can see we have the RBD object, and if I add, here as you can see we have the RBD object, and we also have the RBD solver, and here we have the RBD solver. Any kind of simulation, all of these simulation has an object. It needs the object to store your information inside of DOPS. And to actually calculate the simulation, we have the solvers. So because we are working with smoke, let's create smoke solver. So in here, we can type smoke solver, and here as you can see, we have these two solver, but we're not going to use this smoke solver because it's a non-sparse. We are going to use this smoke solver sparse version. So let's add this, and here you can see this one has multiple inputs, and if you hover over to these inputs, you will see some information, and the first one is always the objects, and here as you can see it says object. we will need to connect the smoke object into this object. And in here, down here, we have this outputting. So we are going to just connect this in here so that we can visualize. And here you can see we have a container. And that container is coming from this our smoke object. And onto the smoke object, we have the voxel size that will control the overall resolution of our simulation. And here we have the position. I can play around with the center to move this domain. Let me change this back to 0. And now to actually import our source into DOPS, this source, we need to create a volume source node because we are working with volumes. Here you can see VDB is in a volume. So in here, let's import our volume source. So let's type volume. And here you can see we have the volume source node. Let's add this. And for connecting the sources, let me hover over to these inputs. And this one is the advection. And here we have this sourcing. So which means we need to connect our source into this input of our smoke solver. Okay, it has been connected. Now let's bring up the parameter of volume source. And onto the volume source, at the very top, here you can see we have the input method and it's set to SOAP, which means I can just pick my SOAP node that I want to import. So let's click on it. And here we have this window open. So in here, we need to dive inside the object. And inside the object, we have the geometry container. And in here, I like to import my VDB from polygons node because that is the node that is creating volume. So let's hit accept. And with that, we have imported our source inside of DOPS. And in here, let me bring up my play bar and let's hit play. Okay, so nothing is happening, and that is because this very first frame or this domain is actually smaller. If we go back, and here as you can see, we have this volume very big size, and inside of the DOP or the smoke object, our container size is smaller. So to fix this, we need to go into the volume source node, and in here just enable this option, enlarge fields to contain sources. So if you enable this, it will enlarge all of your fields, all of your this container size to contain all of these sources. So let's dive inside the topnet and hit play. And still I'm not getting my sources, and that is because we need to go into the volume source node. And in here, we are actually not importing our volume. And to actually import this, we have selected our SOAP path, but we are not importing this density volume. Here as you can see, we have this volume. We need to import this density volumes separately. So to do that, let's dive inside the topnet and inside of the volume source. And at the very top, we have this initialization. So let's click on it, and here as you can see, we can initialize these sources because we are working with smoke simulation. So let's click on this source smoke, and when you click this source smoke, and here as you can see, we have some of these fields. Okay, so the 3 fields has been created. So the source volume, we are importing our density volume, and target field is the density. The volume inside of DOPS are called the fields. So the fields mean that we are working with DOPS, but they are actually the volume. So the source volume is density and target field is density, which means that our density volume from source has been imported into our density field of this DOPnet. And onto the source volume, we have another volume that we are importing, the temperature. And we are also importing the volume V for the velocity. But in here, we only have created one volume, this density volume. We do not have any of these volume. We do not have temperature volume or the V volume. But that's fine. We will see how we can create and import them. But simply, we are now just importing the density field. So now if I hit play, And here as you can see, our source has been imported inside of the top net, and it is our this volume source will gonna import our source every frame because of this activation, because activation is set to 1, which means that every frame we are adding our source. So that is why here as you can see, our this density volume has been accumulating. If I go back and hit play, and here as you can see, it's getting thicker and thicker because we are adding up our fog volume every frame. But right now it's not moving. That is because there are no forces acting on it. And to actually make our this simulation move, we need to create some sorts of forces, and these forces will move our this simulation. First, let me take care of our this importing source issue. It's not an issue, it's an expected behavior because we want to import our source every frame. But for this one, let's see how we can animate our this activation parameter to only import our source at certain frames. For example, I'm going to add an a keyframe, and to add an a key to your parameter, press and hold the Alt key and left mouse button onto that parameter, and your parameter will turn into green, and it is indicating that the keyframe has been added. And we can also see the green mark inside of our play bar, which means that we have an a key at the very first frame. So I'm going to just maybe let's go into the frame number, let's say 8, and in here I'm going to just change this value down to 0, and now we need to press and hold the Alt key and click to add another keyframe. So now here as you can see, we have these 2 marks, which mean that we have these keyframes. So now let's rewind and hit play, and here as you can see, we are importing our source at these frames, and now we are not continuously importing our source, and that is why our this density volume is not getting thicker anymore, because we are just not importing our this density volume every frame. So that's how you can actually animate your sourcing if you want your source to be imported in certain frames. And now let's create some forces to make our this smoke move, and we can create some forces if you type gas. And here as you can see, we have all of these nodes. So all of these gas nodes are designed to work with the smoke simulation, pyro simulation, and some of these gas solvers are for the flip simulation as well. But these are the macro solvers that will drive your simulation. And in here I'm going to create an access force. So if you type gas access, here we have the gas access force. So let's add this, and to actually connect the force, let's hover over to these inputs, and here you can see the very last is for the forces, which means I need to connect this in here. So gas access force has been connected, and now let's hit rewind and hit play, and right now I can see something is happening at the very center. If I zoom in and let's hit play, here you can see something is happening. Our smoke is moving, but let's change the parameter of the gas access force, and we also have the manipulator of this gas access force as well. So which means we need to select the node. So when the node is selected, hover over to the viewport and press enter, and that will enable its handle its manipulator. And here you can see we have the active manipulator for the gas access force, and here we have this cylindrical shape. I can just click and drag to increase the radius, and here we have this arrow. What this access force will do, it will rotate, add the rotation force along this axis, along this cylindrical axis. So which means that we are going to rotate this smoke simulation around Y. Let me make its size bigger to increase its height, because let me hit play, our source has been aligned in this way. I'm going to just rotate this force, So let's use its rotation handle, this Y rotation, and I'm going to rotate this like so. And maybe let's rotate this in here, and let's move this cylinder down. And now let's hit rewind and hit play. And now here as you can see, our smoke is moving inside of this axis, and right now its speed is slow. So let's go into the gas access force in here, and in here we have some option. So these are the start and end points that we are adjusting with these manipulator. Here as you can see, these values are changing. So I'm going to just maybe rotate this down here, and we have the global strength, and in here we are applying this as an a directional drag. Then we can change this to full drag, or we can apply this as an a force. So let's maybe change this to force to have a higher impact of our this gas access force. Now let's hit rewind and let's hit play again, and now we should see some force. And right now its strength is too weak. Let me rewind. We can either increase the global strength. So let me play around with its slider, and let's increase this and hit play again. And now here as you can see, we have this higher force value. And let me rewind, and we have some other parameter. We have the suction force. We can enable this. What that will do, it will suck our smoke inside of this cylinder. Let's hit play, and if I were to continue increase its strength, it will just suck our this smoke simulation around inside of this cylinder. And here as you can see, we are moving our smoke inside of this cylinder. And if I go into this level, here we can see that this smoke has been sucking inside of this cylinder. That is the suction force. Let me change this back to default. And we have the access force. We have this option. We can increase the speed, and we have the speed ramp, and we also have the strength to actually increase the strength of our access force. And we have the orbit force. The orbit force is the rotation force, the force that we have this, where we have this arrow to rotate our smoke simulation. So let's go into the strength, and maybe let's play around with the strength value, and let's hit play again. And now here as you can see, we are rotating our smoke inside around our this Y axis. Let me go back, and in here maybe let's play around with our this cylinder shape. I'm going to just make this value smaller. Let's hit play again. Let's move this down, and maybe let's increase the size overall. And here as you can see, as I am increasing the size, I can interactively change my smoke simulation. Let's hit play again, and sorry, let me stop my simulation. And here as you can see, whenever we are in the DOPS, we have this, right now we have this yellow indicator. And if I were to go back and hit play again, and now we have this blue. This blue bar means that we are caching our simulation into our RAM. Okay, so that we have, if we can scrub, and here as you can see, I can easily scrub. That is because these simulation frames has been stored inside of RAMs, which means when we are scrubbing, we are not actually calculating, we are just reading the information from our RAM. And if you were to change your settings, let's say I'm going to just interactively change this size. Let me move this around. And as I have moved this around, this cache has been turned into into orange. This orange means that our cache has been outdated, and this cache is no longer valid, which means that we need to calculate our cache again. So if we were to move back and hit play, and if no interactive changes has been happening, and this will turn into blue saying that our cache is accurate and we can use this cache. So if you were to just change some parameter, let's say I'm going to just increase the global strength value, and here you can see as I have changed the parameter, our cache has been gone because we have these changes. And same way, let me select my this cache access for and enable my manipulator. And if I were to move this in here, and here you can see as I have moved this, our this cache has been changed to orange again, saying that our this cache has been outdated, and which means we need to calculate our this again. It's just an A indicator. So let's go back and hit play. So we are caching our simulation into RAM, and let me activate my view tool, and let's go back. And in here you can see, if I were to view my DOP.NET, I cannot see my smoke simulation inside of SOAPs, and that is because we need to actually import our this simulation data back into SOAP as well, because right now our this simulation data only lives inside of DOPS, inside of the dynamic operator. And to actually import this data back, we have a node called DOP import. So if you type DOP, and here you can see we have this DOP import, and we also have the DOP import fields. Because we are working with smoke simulation and the smoke simulation or the pyro simulation, we are working with fields. Fields mean the volume inside of DOPS are called fields. So because we want to import our this volume information, or this volume simulation, so let's add a DOP import field node. So let's add DOP import fields. Let's add this, and in here I'm going to bring up the parameter of this node, and in here we need to define the DOP network. We know that we want to import this one from this DOP.NET. Inside of the DOP import, let's click on it, and I'm going to just pick my this DOP.NET. Okay, that is the DOP network, DOP.NET 1, hit accept. That is the DOP network, and we need to say from which DOP node that you want to import data from. We know that all of the data has been stored inside of this smoke object. So we need to select our this smoke object, because that is the object that contains all of the fields. So let's go back, into the DOP import field, and let me select my this smoke object sparse, hit accept. And now we have some preset. If we click here, we have some presets that which fields that we want to import, and I want to import my smoke simulation. Let's click on it, and it will import all of our fields inside of SOAPs. So which means I can view my this DOP import field node, and here you can see we have our simulation information imported inside of SOAPs. And if I were to middle mouse button, here you can see we are importing 5 grid volumes. You know that grid volumes are Houdini volumes because it's in a simulation. It works in the grid volume, and we are importing density field and the velocity X, Y, and Z, and we are also importing temperature fields. So that's how you can create your DOP simulation, and how you can import your source from SOAPs into DOPS, and how we can import data from DOPS back into SOAPs.